Alright, final problem. Two parents have each built a toy catapult for use in a game at an elementary school fair. To play the game, students will attempt to launch ping pong balls from the catapult so that the balls land within a 5 centimeter band. A target line will be drawn through the middle of the band, as shown in the figure below. All points on the target are equidistant from the launching location. If a ball lands within the shaded band, the student will win a prize. The parents have constructed the two catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launch 40 ping pong balls from each catapult and measure the distance that the ball travels before landing. Distances to the nearest centimeter are graphed in the dot plots below. Alright, A. Comment on any similarities and any differences in the two distributions of distances traveled by balls launched from catapult A and catapult B. You're ultimately just going to use socks to compare these two dot plots. So let's start with shape. The shape of the dot plot representing catapult A is mound-shaped as compared to the shape of the dot plot for catapult B, which is approximately normal. Is that true? That looks like a mound, and that looks approximately normal. That is true. And people will have different answers, so there's really not a right answer for this. Catapult A has 3 outliers at 122, 148, and 155 centimeters, as opposed to catapult B, which has 0 outliers. Is that also true? Well, it looks like catapult A has one here, here, and here. And yes, you did the whole calculations with the interquartile range and the 1.5 and yada, 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 that thing. See, these are your quarter 1, quartile 2. And there's no outliers here. And you did the same calculations for this. Here it is, the center. The median of catapult A is 136 centimeters, which is lower than the median of catapult B, which is 138 centimeters. And how'd you calculate that? Oh, okay, well, what you do is, there are 40 dots here and 40 dots here. See? And you divide it by 2, split in half, and then you just go 20 from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, boom! That's your 20th number, and that's 136. Same applies to here, just go 20, and that's your median. That's how you got those two medians, that and that. Next, there is more variability in the dot plot of catapult A, and is that true? Yes, this goes pretty much everywhere. The spread is larger on catapult A than B, definitely. The first and third quartiles of catapult A, which are 133 centimeters and 138 centimeters respectively, are less than those of catapult B, which are 137 centimeters and 140 centimeters. Is that also true? Yes, that's it. Going back to A real quick, just remember that when you're comparing two graphs, don't use the word while. Okay? Anyways, B. If the parents want to maximize the probability of having the ping pong balls land within the band, which one of the two catapults, A or B, would be better to use than the other? Justify your choice. Alright. You put catapult B is the better choice of the two because the distances are more consistent and vary less about the center. As you can see, that's true. There are less, like you said, variability, I think. Well, this has a bunch of outliers. This is just kind of consistent. It stays kind of clustered around the middle. And also, there are no outliers in catapult B, making it the better option. Okay, C. Using the catapult that you chose in part B, which you chose the catapult B, how many centimeters from the target line should this catapult be placed? Explain why you chose this. Alright, and you put, the catapult should be placed 138 centimeters from the target line. This is because the distribution of catapult B is fairly symmetrical. That's true. Since there are many values clustered around 138 centimeters, there is a high probability that the ping pong balls land in the target band. As you can see, that 138 is also the median, so keep that in mind.